Hello, welcome back. All right, we're going to be doing some stats. This is the last section in Chapter 2 and in Unit 1 that the College Board has put together. And the first thing that we normally do is I would either take, in this case, is 80 AP statistics scores from Chapter 1 test. And notice here, the distribution of Chapter 1 test is it approximately normal? We don't know. How would you go about figuring out if this is normal? And this is something that I would normally ask you guys and your teams to go through and do. You'd have teams of 3 or 4. And you guys can go through and brainstorm and just kind of see what's going to happen. So right now, what I would like you to do is hit pause and just think through everything that we've done in Chapter 1 and Chapter 2. What types of things would be helpful to either prove the fact that they're normal or would at least get you to the point of saying, yeah, it's probably normal. All right, I'll see you in a second. A couple things usually come up. Somebody will usually say something along the lines of, hey, check the 68, 95, 99, 7 rule. Of course, that comes up, how would you go about checking that? But, you know, it's a good thought you're thinking through and playing around in, especially when you've got groups of people talking. You can kind of come up with that. Somebody will usually say, well, we know that the mean drifts towards the outliers, so maybe if we compare the mean and the median, that would at least tell us some idea if it's the same. Seem a little laggy here today on one of my laptop cameras, sorry. How about graphing? What would you have to check? So we've got, what types of graphs do you have? We do dot plots. That would give you kind of a good idea of the shape. And I'm going to go ahead and put stem plot in there because those two are kind of the same. Kind of give you the sense. And actually, well, histogram, I suppose. Stem plot is a histogram, but you also get the data like you do in the dot plot. You also do box and whisker plot. Okay, so I want to show you a couple different ways that you can get some of that information, and then we'll talk about a really good way to do it. So what I did, and I was going to do this on Staplets, but apparently the website is being slammed by all the people who are already in school. So I'm going to do it here on my handy-dandy calculator. So, couple of things, and depending upon who you had for previous classes, you may or may not be comfortable with using your calculator. But this is kind of one of those times you're going to be like, oh my goodness, this is really worth the $100 and some odd I pay for it. If you hit the stat button right here, that's going to allow you to enter in data. Specifically, you're going to go in and hit edit. List 1 right here, I have entered all 80 pieces of data. A couple of things to remember in the back of your head. And I'm going to have to say this a couple of times. But, oh, before I forget, in the notes that you have, the last page or 2 is all the TI-80 something notes in terms of how to enter stuff in and things. So that might be helpful for you to double check, print out if you can. Excuse me. So if I hit delete up here like on list 3 disappears. However, it's not gone. You're not clearing out the data for that. If I want to clear something out, I would actually hit clear and it would list, like here, watch. If I go down here in list 4 and I type in a whole bunch of stuff, and let's say I do the same thing for list 5. Okay. If I hit delete, it goes away. However, if I bring it back here in list 5, the data is still there. It's just taking it off your screen. If I go over here and I hit clear, all the data down here that was down here in the bottom, it goes away. So now if I hit enter, now it gets cleared out. So again, notice up here, it's all this, it lists everything out there. If I go up actually up into list 5, it's a comma separated list of values. If you see your list gone and you don't want to do it, what you can do is if you go back out to the main screen, and then go to stat, stat, and you're going to run the setup editor. If you run the setup editor, it will just go ahead and put everything back into list 1, list 2, list 3. So if they're out of order, it'll do everything that you need. Now, it's not going to look like it does anything, but once you go back into stat and edit, everything's there. So in fact, there's list number 5, list number 6, all of it. So, a couple of things. Let's talk about how you plot things on a calculator. Notice here, y equals graphs, lines, and curves. Up here right above it is stat plot. Generally, and this isn't perfect, but everything in the blue up here kind of gives you a sense of ways that you can manipulate the data or manipulate the looks up there. So if I go to stat plot, I'm going to go over here, and on plot number 1, I'm going to hit enter. I'm going to go into it. Now, depending upon what operating system you have and what calculator you have, you may have these all on one line, or you may have them on 2. If you can't, the only way you can do it is continue to go to the right. So if you have these last 2 or 3 icons right below the first 3 icons, you're going to have to continue to go to the right to get them. Anyway, so you've got a regular dot plot. You've got a connected dot plot. Over here you have a histogram. So if we were to do the histogram, if I were to run it, now what you can do, notice if I go to zoom stat, I press number 9. You can either arrow down or press the number 9. It's going to go ahead and kind of zoom it in on the data, which is very helpful to at least get an idea of where things are going. So there's my histogram. Looks a little potentially skewed left, but you know, let's see what else we got. If we go back to stat plot, I can do a box and whisker plot. Is there any outliers in that list? Again, let's find out. Oops, should hit zoom 9. Okay, so we have 2 outliers in that list. Now, we're not sure what the mean, the median, the mode, standard deviation is. We'll get to that in a second. But we do know there's some outliers, which makes some sense. And then last but not least, let's go up and do G. Yeah, and then there's a regular dot whisker plot there. So we'll get back to one more thing here in a little bit. But if you go to stat and go over to calc, let me go do that slower. Main screen, stat, go over to calc. And again, if you don't have one of these types of calculators yet, remember you can actually download. We've got it set up here at school that you can get 2. My pictures are frozen. My pictures are unfrozen. You can download the app from the Google Play Store for your Chromebook, and then you can use that. Again, it doesn't take the place of this because can't guarantee if we end up going back full time that you'll be able to use your Chromebooks on the AP exam. So you want to make sure that we've got this to some extent, that you've got one of these that you can use, and because it also feels different and it also goes faster because you can just type in it instead of having to move your mouse around. Anyway, so one variable statistics. If I run that, frequency list just says, for example, if we had a list of values and the other list would be how many times each of those values happened. I just typed them all in as we saw them. So I'm going to go down to calculate, and it's going to run everything. Now notice here, it gives us our mean. Our mean is 79.7. Our standard deviation is going to be 8.67. You've got your 5-number summary right here. My median is 80. So it kind of gives us an idea of, hey, is this normal or not? Now, sorry, I thought I had shut that off. My apologies, or put it on silent. I did. It's my mother. Here's a question for you, however. So we kind of have this shape. Remember, let me bring this back here. A bit of a glare. So you get that, right? So we kind of have, is it skewed? Does it make sense that it's skewed? Let's talk about what's going on here. So if this was a standard normalized curve, we get something like that. My median is 80. My standard deviation is 8.67. Just for grins, we're going to say 9 because we need a rough estimate. Makes the math easier. So I have a standard deviation over here at 89. The standard deviation over here at 71 because I'm going to go below. 2 standard deviations below would take me down to, what, 62? And then down over here to 53. If I go up 1, we go up to 98. I know, some of you guys got it already. Where's your 3rd standard deviation? It's going to be up here at 107. Mom's just talking about the Amazing Race that they're rewatching on Amazon, so don't worry about it. Now, what's the highest score you can generally get on a test? We've got this maximum score right there, right? So does it really make sense that we can go 3 standard deviation above the mean? Or excuse me, the median mean. So because of that, you're going to get a pile up of data here to some extent. In fact, if I check the histogram, we've got what your maximum is. Oops, let me go back. So your maximum score here is what, 93, but it all kind of gets piled up here. Or even if we got hundreds, that's as high as you could go. So, you know, just going purely on that, it's not going to necessarily work. So what we end up coming up with is something called, I'm going to pick a new color just for grins. So here's the new idea. Okay, it's called a normal probability plot. Okay, this is done on your calculator, so you don't have to worry about trying to do this all. And that's the last on our list of things here when we go to stat plot. It is this final option here. I'm waiting for there. It's my final option right here. So if we arrow over, zoom stat, we get a graph that looks like that. And what ends up measuring, actually I think it says it here. So I've got list 1 for your x on your, hold on a second. Okay, so data's going the x-axis. Got it slightly confused there for a second, sorry. So what ends up happening here is that you get all this data. We're measuring the x-axis here. X-axis is going, I mean, all your data values is going along the x-axis. And the potential, or the expected z-score is going up here and down on the y-value. So if I hit trace on this, I'm not sure why my computer's so laggy today. You can't see this, and if I go really close, it's going to be a little bit harder to see. Oh, there you go. Okay, 57 is 2.5, is expected to be about 2.5 standard deviations away from the mean. If I continue to go over a score of, and notice they're just kind of piling up here. You know, the score of 74 is expected to be negative 1 point, or 74, waiting for it to catch up. So 74 is about a negative 0.9 standard deviations below the mean. Interestingly enough, if you've got data piled up, they're all given different standard deviations. But, you know, it is what it is. The takeaway from this is this. If this is relatively linear, so let's go ahead and plot this out. So we've got something like that, okay? So over here is expected z-score. And this over here is test scores. Remember, always label your axes. Okay, so if a normal probability plot is approximately linear, then remember what we call this, where we have all the dots all over the place? It's called a distribution. Distribution of test scores is approximately normal. Why do we care? Let me tell you. What happens when you do a study? Do you think you know that if the data is going to be normal or not? You don't. Okay? When you're looking at all the data coming in, you have to know, does this appear normal? If it appears normal, we're going to be able to go through a set of rules. If it doesn't appear normal, then there's going to be some other things we're going to have to worry about. Or we're going to say, hey, something's going on. So we're going to jump over to the formalize section here. I'll see you on the flip side. We'll talk to you soon.